Hello everyone again. Evening, dear colleagues. So quite recently the DDoS talk was completed. Now Alexander Denisov came back to us. It's a participant of the battle. He's gonna talk about Flutter for web. It's not just there, it's there for actual development. Sasha, the floor is yours. I think you're muted. Right, hello, what about now? Can you hear me? Lima Charlie, loud and clear, affirmative. Okay, so yeah, I'm greeting the guys who have just joined us. I've greeted the ones that have been there in the first place before, but anyway, hi everyone again. Thank you for the introduction. My name is Alexander Denisov. Indeed, we've raised this topic. During the battle, the topic of Flutter was raised. What Flutter can do, what it can't. Ultimately, it's almost all-powerful. Anyway, people are used to thinking about it as a cross-platform, as kind of a tool that helps write applications. However, in this talk of mine, I will tell you why it is not necessarily the case, about other opportunities, other capabilities of Flutter in the context of web development. Since our today's conference is not about Flutter alone, my assumption is that there's a proportion of the audience that have never used Flutter for coding. They might be unaware of the basics, so let me throw in a couple of points for them, some generic concepts in Flutter, and then we will get down to the details, to the specifics. Right, Flutter. It's a cross-platform framework developed by Google. And originally it was intended for code writing for iOS-based apps and Android apps using Dart language. Dart is also a language that was developed by Google. Literally this morning, earlier during the day, we analyzed its history. Dart was put together by a bunch of enthusiasts in Google that decided that the JavaScript has some fundamental flaws, inherent flaws. So they decided to, create something akin to JavaScript, but deprived of those flaws. And they made Dart. I don't think that they wanted to take the world over with Dart. Maybe they just made that language for themselves. The history is silent on that. However, Dart, as a development language, it did not take over the world, indeed. A certain expansion on the web world never happened. Ultimately, other browsers refused to support it. Ultimately, Dart is compiled to JavaScript, and there are several frameworks that you can use for Angular Flow Dart. Well, Angular Dart, not Angular for Dart, but Angular Dart. So that's the framework you could have used to write on Dart. But 2015 came around, I think, if my memory serves me well, and Google got this new idea to create a framework for cross-platform development. It was codenamed Sky at the time. They had to pick the language to go with it, and they said, "Okay, Dart is there. Let's go ahead and use it." This is the language that can be customized, that is customizable. At some point, I was talking to a guy at Google I/O. The community guys keep asking me, "What not Kotlin? Kotlin is fine and nice, nice and dandy. Why haven't you? Why did you end up using Dart and not Kotlin?" Well, there are certain official reasons for which it's Dart that is used in Flutter, not something else. I might as well mention that a bit later down my talk. But say this guy, let's say his name was John. He's from the Dart team. If he wants, if I want to develop something, I just approach John and I say, "Okay, that seems like a great feature. Let's hardwire it into Dart." And since 2015, 2016-ish, Dart picked up in the development pace. But it is now a language for dynamic development. Statical typization typing, it went away. it became more and more advanced. To which end? Well, because the compilation size is very important in mobile world. For static typing, you could ahead of time assembly could have, well, yeah, there was a issue with that. So Dart got smaller, more compact. So now Dart is now there is a certain development vector for Dart. The language becomes more and more advanced, but we seem to be talking about Flutter, so let me skip Dart for now. Now, what is the key feature of Flutter? Why did this talk see the light of day? Why am I talking to you right now? Because quite recently, depends on how to judge, literally March this year, quite recently, Dart is, well, got released 2.0. 1.0 was in 2018. In 2021, it hit the 2.0 milestone. 2021, right? March 2021. Thank you. Right. So Flutter 2.0, 2.0, not Dart. So how is Flutter 2.0 different from previous Flutters? This is particularly due to the fact that it's no longer a cross-platform framework. Yeah, by the way, it's a 2.5 version. That slide, it's even 2.7. The slide is a bit outdated. 2.7 is the most recent version of Flutter. So Flutter is no longer cross-platform framework. It's a multi-platform framework, or portable, as Google refers to it. It can be ported to various types of devices. So you can do apps for mobile devices, for web devices, for web-based apps, and for desktop. I mean, Flutter apps can be run on macOS, on Windows, on Linux. However, this direction, the most recent direction, is quite raw, quite crude. There's a bit of raw stuff there. It is being fine-tuned, finalized as we speak. Basically, they are taking snapshots from the Channel A version and they put it into stable. So this is how it works. This is how it works at this point. Right, so we're talking about not Flutter for desktop, it's Flutter for web. What is it? So, is it a trembling creature, or does it have the right to live? Requoting Dostoevsky. Flutter for web. Is it a trembling creature, or does it have the right? That's Dostoevsky on Flutter for web. Right, let's get down to the bottom of this. Let me start out by explaining the modus operandi of Flutter as a framework, the MO. So let's check out the native mobile app. There's a platform bit, and there's widgets, there's canvas on which the rendering happens, and there are certain events that are generated by the user or users, some user-triggered or user-generated events. And there's a bunch of services that the platform gives, like location, sound, audio, camera, sensors, Bluetooth, etc. And there is an application, left-hand side, native code. And to render something on the screen, that app requests or sends requests to the platform widgets, OEM widgets, the components. And this is the way of it communicating with the platform services directly. So everything works like a charm, right? Flutter is there to make sure that various types of devices can render stuff properly. It works a bit differently. It does not work with the platform widgets. It uses its own widgets and it renders them itself. It just picks the canvas and draws on it, renders to it directly. And for a Flutter-based app to look as a native one, there is a bunch of widgets that are look-alike to the native ones. So I'll talk about this a bit later on. Right, anyhow, the platform channels are supposed to be invoked. There's got to be some APIs for iOS or for Android. So there is a certain platform channels mechanism. Depending on the system, there are under the hood ways to interact with services, iOS-based or Android-based. This is how it works. So ultimately, bottom line, if we are rendering it ourselves and the code is just the same, what we have as an outcome is this. It's going to look absolutely the same on Android and iOS. I mean, we've coded it, we've launched it on both platforms, the canvas is the same, everything got rendered the way we wanted it to. However, essentially there's almost no difference. There are some widgets that understand which platforms they work on. For example, that arrow, that back arrow. On iOS, and the back button on Android, they look a bit different. Well, simply because Flutter realized the platform is running on, and it puts the different kinds of arrows for the back button. Out of the box, like I said, there's a bunch of widgets that were written by the Flutter team. They look just the same as the native components in Android and iOS. Essentially, if we want the app to look as native as it gets, as native as it can get, and on iOS is a native iOS app with all the native buttons there and other components, and the same for Android. It's supposed to look as an Android app on Android. Then we have to make two different trees of widgets, separating them, iOS and Android separately. Or some layouts can be generic, and the views can be adaptive. So this is a bunch of speakers here. So Cupertino v material example. So the arrows look a bit different depending on the platform. I mean, the Flutter realizes, Flutter identifies the platform and adjusts. So it's kind of for custom UIs, right? The less the difference between, or less significant the difference between iOS and Android, the easier it is to code. So if there is stuff that looks great on both platforms, no distinctions necessary, this is as resource sparing technique as possible. Right, we were kind of going to talk about web, but we're talking about mobile dev. Well, Flutter was originally designed for mobile development, so I couldn't avoid that. So Flutter in web. Let's have a look at how it works, not natively, but on the web. You remember that picture from before, right? Now let's imagine that instead of a platform, what we have is a browser. It's not a platform, it's a browser. Bam, like this. Bottom line, nothing changed in principle. So we have just the same code, Dart code, that is just the same as on the mobile platform. We have just the same kind of widgets. It's just they're rendered not on the canvas of the mobile device, but they are rendered in browser. And since the API in browser works a bit different compared to the mobile devices, and Dart can compile to JS, and it has a JavaScript interop, then the interaction with web services in the browser doesn't work through patterns. It works directly through JS interops. We can invoke them directly. And ultimately, the code in the application is roughly like almost, it's close to 100%. I will not cite you the exact figure, but let's say 90% the code is the same. I mean, we don't have to alter the code. We can run the same app on in the browser. It's going to work. So how come? How does it happen? Let's check this out. This is a framework architecture. On flutter.dev on the web, you can see something like this. The lower tier is the engine layer that involves working operation with Skia. Skia is the 2D engine that gets everything rendered on the mobile devices for Flutter. The Dart VM is operating just right there, text renders, etc. So all of the interaction with the mobile platform happens there. Then there's a framework level that is written in Dart. So it's kind of like an engine. It's open source. I mean, you can get under the hood and check out what's what. But it's that framework is written in Dart, and there are certain components that are in charge of rendering, animation, painting, gesture processing. There are widgets, the out-of-the-box stuff, and some themes from again out of the box. And there is the upper tier, upper level, which is predominantly coded by the developer. This is exactly where the code is contained, written by the developer. And there are some plugins that you can also, some plugins and packages that you can hook up as well. Flutter for web is essentially the same except for the lower part. The lower tier gets replaced. So in Flutter's engine, it just starts working in a different direction. And for rendering, the stuff like, it's not exactly skier, right? It just goes ahead and starts drawing, starts rendering with HTML, CSS, sometimes with Canvas, sometimes WebGL and WebAssembly are involved. So I'll give you the case analysis in which cases what is used. So different scenarios are possible, but the same widgets are used. And right, the web view is, you don't have to do that. There's no such thing in browser, right? So all we can do instead is show the stuff that we were supposed to show on the mobile device. The same is displayed in browser. How do we get there? Well, it's essentially due to the fact that we use different compilers. When developing for a mobile device, we have two special compilers. This JIT, just-in-time compiler, and on Android it's essentially the compilator, the compiler, and it's the interpreter on iOS. So stepwise execution, debuggers, profilers get on top of it and help debug the code in the debugging mode. Code reloads and then stuff. So hot reloads. Hot reloads, if you're not unaware of that mechanism, it's not part of the native development. It's React has it as native. We can alter some code, and hot reload we will see how it looks on the phone screen without restarting, without cold reload. And that accelerates development because larger apps take longer time to be put together. And then there's dev compiler. Well, there's the deploy mode AOT plus runtime on top, right hand side on above. And there's a profiler. If it's in release mode, even the profiler is omitted. So again, they cut down the volume big time and they improve performance. For web, the lower bit, there are two different compilers. Dart was originally capable of being transformed, of being compiled to JS. So this feature is actively used here. It's a dev compiler, it's a JavaScript compiler that is bringing along a whole bunch of features, a whole bunch of tools that simplify debugging and other developer-related stuff. And there is a Dart 2.js, the deployment. So based on the Dart code, it generates optimized JavaScript code, which ultimately gets executed in the browser. So ultimately, our Flutter software, our Flutter application is launched on browser, launched in the browser with those two things involved. There are two ways to render it, to render our app in browser. There is HTML rendering that from day one was there in Flutter for web, and because of that they thought that it's slowing the whole thing down because it uses DOM canvas, DOM canvas APIs. Based on the widgets of Flutter, it generates the tree volume, and it generates it, it renders it. If it's too big, well, performance-wise, it didn't perform well enough. However, at the same time, the size of the web app was quite appealing. I mean, it wasn't huge, but it was about performance rather than the size of the app. So they came up with the second way, the so-called canvas kit of rendering. So this, that skier that I've mentioned in mobile development is invoked. It gets hooked up as WebAssembly, and then using WebGL, the same things as with OpenGL or Meta on iOS and Android is performed. Performance-wise, everything is nice and smooth. However, since the application gets this WebAssembly plus Skia, the minimal size of Flutter app grows by gigabytes at least. 2 megabytes for a mobile app, well, that's not the best thing. It's not really pleasant. Then you can run your application and render it this way or the other. By default, the software, the application is configured in such a way that if we open it on a mobile device, we end up using HTML. If it's on desktop, then CanvasKit. Why? Well, the intention is well, to avoid poor bandwidth or poor network connection on the smartphone. Well, it might be the case. Right now my mobile internet is performing well, but it's not necessarily the case at all times. Now let me show you how it looks. I've picked up the app as a case. I wrote it for a workshop on Mobius, and I coded it live. You might be aware of this conference that we in Russia run. So I coded the software live, and I showed the stepwise implementation like a store Planet's Market, Planet Store, Planet Market. So if you open a planet, if you hit it like this, there are some details with animation, so these details are rendered. So I picked up that app and I launched it in the browser, and it worked. It worked like a charm. Since the user interface was made responsive from the box, you can change the screen size and everything works like a charm. Again, the animations work, and there's animated effect when you click on the planet. It is displayed like with the blows and whistles attached. So with bells and whistles attached. So the next thing you do is you just select the other target with the browser. However, if we were to compile an application with two different render types, the result will be different. If you open DevTools and check out how the HTML rendering compiled application looks like, we see that different components are formed from different elements, using different elements. For example, the layout of this frame is div. The P for the planet name, IMG for the picture, but it's not always the case. Sometimes it's canvas. If it can grab the style and use it, it uses the style element. Otherwise, it uses canvas. It makes this decision at the time of rendering. So ultimately, it's kind of a put together potpourri. Sometimes it's a canvas, div, P, IMG, and so on. It's a mix of bits and pieces. However, if we were to open an app with CanvasKit, it's one big canvas that contains everything. That's it. That's the end of the road. No separate elements. Code-wise, left-hand side, right-hand side, HTML v CanvasKit. And the first part only shows the part of the code. I mean, you can scroll down time and time, a couple times. So volume-wise, the second one is bigger. So the big question is, which one do you use? Which one of the renderers are you supposed to use? Well, it all depends on how big a tree you have there, how complex the widgets are, how strongly you value performance, how much you value performance, how critical the size is. You can use the Flutter team advice, the tip, and you can code the smartphone to launch HTML and CanvasKit on the desktop. You can pre-program it by default. So a couple of links to go with my talk, so that I have something to show for it. So this is basically the Planet's Market as I coded it online in live mode. So there's a bunch of links to go with it. There's YouTube video in the GitHub repository, and the HTML renderer plus CanvasKit, two app types, and there's a QR code for you. Well, QR code is a bit of a new black today, so scan the QR code. It's for the lazy people to get the YouTube video fast. So it kind of looks simple. However, it's not necessarily the case. There's a bunch of pitfalls in there, like always. So first of all, since, well, even though Flutter for Web has been released, it's in initial release phase, and the number of scenarios is used by Google alone. I mean, you can use it any way you want, but Google can only recommend, and does only recommend, working for these scenarios, not others. Others are at your own risks. Since Flutter is a PWA out of the box, it's one of the scenarios. If you want your mobile app, if you want to be able to use it as PWA, you can compile it for web and use it as is, as such. Single page app, an SPA, if you want that, yeah, that's Flutter. Expanding existing Flutter mobile apps to the web, that's another usage scenario. It's quite frequently used whenever you have a ready-made Flutter mobile app and you want to port it to web without too much effort. This is the way to go. Right, let's check out the outcomes, what works out of the box perfectly and what doesn't. First of all, it all kind of seems the same. I mean, it is the same, but what's missing in the web app? For example, say, if you hover the cursor over the element, there will be some highlight out of the box, but there's no such thing on the mobile device. There's no cursor to hover. You can only tap on it with your finger, but hovering works itself on the web. Okay, it's there. I mean, it also works on desktop. If you hover your mouse over this, it works. Right hand side, there's a yellow arrow there. I would like to have something like a scroll bar on the right hand side in browser, right? It's not there. Check out the path in the browser. It hasn't really changed. I mean, there's different screenshots, but I didn't pay attention to it. The screenshots were taken at a different time, each time the different ports were used. So never mind that. The screenshots were taken during debugging. But I'm used to opening a detail and something in the URL is supposed to change. Say I'm looking at Mars. This is Mars, and I want some changes to be reflected in the URL bar. How do you do that? With a scroll bar, there's a special widget for that. You can just wrap it. Our list of planets is wrapped in this, and you have it right there. It pops up. To avoid displaying it on the mobile device, you can verify the platform it's run on, and then, well, you might as well keep it on the mobile device if you want it, but you can get rid of it like this. With navigation, it's all a bit more difficult. For proper navigation on the web, first of all, the URL strategy has to be modified. It works through hashing by default. We want it to operate through slashes. We have to change that, the URL strategy. If it's not Navigator 2.0 that is used, you have to embed it. If you're not a Flutter developer, you won't know what I'm talking about right now. The Flutter developers know it. People were complaining that Navigator 2.0 is a bit too complex. It's not necessarily the case. I mean, you have to take it for a spin for a bit. You have to get experience with it, and then you'll learn it intuitively. So it's not decorative; it's declarative. And out of the box, parsing is possible from URL and back. A route information parser. It automatically captures whatever you've put in the URL bar in the browser, and it parses. Yeah, this parser is everything you need for this to operate properly. However, again, if you haven't used Navigator 2.0 in your app from day one, you will have to walk an extra mile. But other than that, well, it's just about knowing the right thing and doing it. It's quite an easy thing. And in certain cases, we might lose the state. Because of this, well, if we are navigating inside the app, it is maintained. However, if we're navigating inside the app, however, if we wanted to change something in the URL bar and to hit an enter, get there, so Flutter considers that as the new entrance or the new attempt to access the app. So if something was stored in the memory, if the state was not stored in the memory, then you should have thought it beforehand. Because each access through the browser, this is a browser functionality, it just restarts the app. However, if we do navigation 2.0, navigator 2.0, this thing goes away. The browser navigation is also stuff like this. And there's an interesting feature there. The back navigation in the app and back navigation in browser. It's not the same. This is not the same. And it doesn't just pertain to web apps. Gmail works like this as well. There are two back buttons. There's in-app and the browser one. So each transition, each path you follow in the app, it generates the browser, new browser address. Navigation in the app is a different story. For example, if I were to hit this back button in-app, and this will take me back to the list of emails, and then we click the back button in the browser, we will go back to that letter, to that email we just opened. The back browser will have put us back. So this is part of browser history. Sometimes it can get confusing because there are two back buttons. They're supposed to operate the same way. If we're talking about web pages, in web apps, this logic is a bit different. However, you can cause them to work the same way. Instead of the standard back functionality, you can use this web trigger, and you can use the same method for navigation in browser, in-app. Since we're in web, interop is live. We can pull it from the web. The interop is there. You don't have to write JavaScript. You can just invoke it from Dart. The only thing you gotta care about is that those transitions must be invoked only in the web, only in the WebAssembly. So we need to check. We need to run a simple check. Is it a mobile device or a web-based? It's a PC, like laptop. So it's quite easy. This is like comparing the levels. So true or false is the outcome. Or you can run it through conditional import. So you can import a library like this if the Dart HTML is invoked or is connected. You can do it like that. So in web it's one thing, in the native it's the other thing. Defaults are different. The compilation or the assembly is the same, but it works just a bit different in two scenarios. What if you have to embed HTML? Like, why would we want to use WebView in native? There is this widget that's called HTML element view class. There's a class of widgets. So ultimately, you can use this class to render HTML CSS generated by the script. You can just embed it into the code. It will natively embed into the code. If we're working with the Canvas kit, whether it's pure Canvas, it will try to find some gaps in the canvas to try and display this. So with Canvas kit, it doesn't make sense to use many element view things, because otherwise you will lose some performance. Because this way you will lose some performance. If you want to pull the JavaScript, well, the JS library that we're using, you can do it in Dart and then connect JavaScript. You can trigger the interop and get JavaScript out of Dart directly. There are some video players. There's a JS Flutter web player class that helps work with the player. We create the web player interop class in Dart, and they are invoked like this. When we pull Dart, it will pull JavaScript, so everything is going to work like a charm. So what is the most painful bit? Let's talk about pains. What are the bad things in there? Ultimately, what works? What works or doesn't seem to work as well as it should. So have the text is text, and have the text is in Canvas or is rendered in Canvas. There's no way you can put information together from. There are some ways to bypass it. I mean, if you want to implement SEO, there are ways around it. I mean, there could be some elements of HTML view accessibility, but it doesn't work like that that easily. I think that this is not really a high priority. It's not resolved like that. It's not resolved quickly like that. This Flutter page up. Yeah, you can introduce it directly. There's no such thing as a simple solution here, and there are complex way of thinking you have to apply. I haven't seen any forecasts that this gap is going to be bridged anytime soon. So Flutter for web cannot be a full-fledged solution for web app application creation, simply for that reason. I mean, it's a full-fledged complex websites. I mean, you can do apps with Flutter. However, you need to think about how badly you want SEO. Parallel computing in Dart. We've been debating that with Denise today. Parallel computations are based on so-called isolates. A certain process is isolated, and it can some parallel calculations might be happening there. It's not intertwined. It's not overlapping with the parallel process. I mean, it's standalone in that. And you can interact with that other isolate only via ports. You can only do it via ports that you use to broadcast messages, forward messages. I mean, a function, a message, we throw this in and we want a result or an error message. There's no way we can affect that. There's no way we can interfere. Back in the day, there was a serialization, deserialization, I mean, for bigger objects. Now it got fixed a bit. The performance has improved because the styling and destyling, sorry. So it's working a bit better. It's working a bit differently. So right now we're talking about the isolates that are gone. For Flutter for web, it's not a thing. They're gone. I've looked at the source codes. So if it's web, there's no isolates created. It's just a conventional synchronous function is used. For parallel computations, you can throw in some workers, but you're going to have to do it manually. It doesn't work out of the box. But again, I believe this is going to be fixed in the near future. But so far it's like this. So you need to keep this in mind. And another painful bit, another downside is working with the images. Oleg, let me take that back. So how can we render pictures on the web, images? It can be IMG or picture as HTML elements. It could be draw image method on the canvas element, or it could be WebGL. Flutter uses all three methods, all three ways to render pictures. The first two ones are in HTML. The third one is the first two are in HTML. The third one is in CanvasKit. Okay, if the picture is in memory or inside an asset or in the same origin network, yeah, everything works perfectly in all cases at all times. However, if the origin is different, this is where the things get tricky. For example, to render an image with WebGL, you need to have full access to the picture. However, you cannot get that, right? There are some workarounds for that, as a course proxy, or hosting your images in a course-enabled CDN, or throwing IMG elements in a platform view, HTML element view. So there are some workarounds for that. You have to be careful about that when the pictures are coming from different origin network. Okay, let's talk about good stuff right now. Upsides, positive dev experience. So there's a small part of Android Studio, how it's run. We just select the target and then we start. Then we click start. I mean, we can do web for iPhone or for Chrome. It's you just have to select the right item initially. That's all. You just have to. That's the hot reload button, the magic button that helps avoid cold reloading. In web, there's a feature. It's not working. I mean, it doesn't work. It can work in two modes: hot reload and hot restart. Hot reload restarts the app quickly, rapidly, saving all the states. All it does is replaces the code. It applies or it embeds the modified code. Hot restart is when the changes have been so fundamental that hot reload doesn't work. The tree of widgets, types of widgets got changed, got altered. When it cannot hot restart, hot reload, the app does hot restart. But the Flutter engines, the Flutter engine, the bulk of the stuff is already running. You don't have to restart that. In web, only hot restart works, not hot reload. Hot reload for web doesn't work. So it takes a bit more time, but it's still, nonetheless, it's quite fast. If you want to build an app, Flutter build web, bam, the app gets assembled. You can stick some nginx on it and then host it. You know, Firebase hosting, whatever. You can put it wherever, and it just gets hosted. This folder is an element now of a web app, I mean. Additionally, in debugging, you can use a whole bunch of very interesting tools in the browser right there, like a visual inspector. We can click in elements with the mouse to check out its properties right there in the browser. And we can inspect any troubles. Performance view, we can also analyze the performance drops where the widget is taking too much time, over 16 milliseconds to draw, to render, and then we can fix the misbehaving widgets. If you like working in Android Studio, if you don't like iOS Studio, there is a special web-based server, and the same the Android Studio, right? If you don't like Android Studio, you can work in a tool like this. Web-based tool. However, the tools for mobile devices and for web, there's a difference, right? Well, you gotta understand that, well, the CPU profile of a browser is not really relevant, okay? But there's a there is a logger, there is a debugger, there is a provider. The interesting stuff is there. Some things I wish to mention is the documentation, is the paperwork. The paperwork is amazing. I mean, flutter.dev, just go there, you can get started just like that. And there are separate articles for Android, for iOS, for React Native, even for Xamarin, for Xamarin, and there is stuff for web developers. However, the approach used there is going to be more understandable for web devs by whoever wrote that stuff. So I guess this is almost it. It's time to summarize. Flutter for web. Is it a trembling creature or does it have the right to exist? The way I see it, it does have a right to exist. Additionally, more and more projects get started on Flutter as one of the additional targets. One of the additional targets is Flutter for web. So quite a lot of quite a bunch of projects are picking up. It would be a bit weird to write web apps only on Flutter. It might seem a bit weird because Flutter is a cross-platform. Unless you have a goal in mind to expand, unless you wish to scale up to other platforms, I don't think that Flutter is the best way to go, not the most optimal framework for you to go for if you're coding for pure web. However, ideally, if you want a mobile app or a desktop app or a desktop web app or everything together and something else on top of it with bells and whistles, well, there have to be some gains from using, some benefits. There are some upsides that outweigh the downsides when all the benefits, all the features of Flutter compensate the drawbacks, the downsides that are there in Flutter for web that you only have to put up with at this point. Essentially, Flutter for web is not a full-fledged framework for web development. It's kind of a part of a cross-platform framework that helps put together quite decent, fairly decent web apps, however, with some constraints, with some limitations in mind. That's about it, guys. So let's deem that it does have the right to exist. If you have any concerns, if you have any issues with that, we can definitely discuss it. This is my closing slide, my final slide. 4 links here. GitHub link featuring some examples that you can poke. Flutter Dev Podcast, and this Twitter, Shurek Denisov, and a link to a couple of podcasts that I host mobile people talks, the one that me and Denise mentioned today, where we're talking about web development from all angles, from all perspectives. And there is a Flutter podcast where there's no Denise, there's another person involved from Surf. We talk about that. So that's about it. Thank you, Alexander. I apologize for butting in 1 second earlier than I should have. I really enjoyed your talk. I really felt like writing something on Flutter, some web app. And you just said in the morning, no, it's only Swift for me. No, thank you. Okay, so there are some questions that I would like to pass over to you. So there's 10 minutes for the Q&A now. We still have that time. So how quick, how well performing Flutter for web is? There is this opinion that Flutter for web is slower than native in performance. I mean, it does make sense. And the second question, okay, throw in the second one. And there's is it ready for production? There's a second part of questions dedicated to that. Is this whole thing ready for production? Okay, question one. With performance, it all looks much better than a year ago. We launched that project, the one that we're running right now, that web was one of the targets there. A year ago, it used to be much worse off. Canvas Kit was not around, and the HTML was slower, HTML component was slower. Now there's Canvas Kit available, plus HTML performance got improved. Canvas Kit, if you're using it, it's kind of like you're running this on a mobile device. It's WebGL invoked, and everything is rendered by WebGL. Previously, the performance issues came simply because of the tree. The tree was too bulky. It was real bulky. I mean, it was impacting the performance big time. In this case, all you have is a pure bare canvas. This engine takes very little time to render, to draw stuff. So if you're using Canvas Kit, there's no such thing as performance issue that you'll experience. There are other issues, but performance is not an issue anymore. It's no longer relevant. What about production? Anything else in production? Maybe some big-time companies have done something for production. You mean right now, stuff in production? Well, coming soon. Let me put it this way. I will not give you a timeline. I'm not aware of the pipeline, but it's coming soon, real soon. Like one of the projects will be pilot tested soon enough. Well, I do know that there are a couple of apps on Flutter. Flutter for web is right now tested. It's in test phase, and it's used for admins, stuff like SEO. That's less relevant for everyone. Okay, but I do know that more and more projects are picking up with this goal in mind, this target web, because it really has become a big upside. It's in release, it's workable, and the customers start believing in Flutter more and more, and now there are 3 targets, not just 2. Well, it used to be Android, iOS, and they were just considering web. Now we actually discussed it during the podcast. They want the web by default as well. Yeah, by the way, I remember there was a survey. There was a survey launched by Google, initiated by Google, and the difference was like 1 quarter. A quarter ago, there weren't too many requests from customers to do it for 3 platforms, web included. Now there's a target for web. So I will not give you the figure. The 90% is well. There's a big increase, a big spike in interest. Okay, so we are living through these times right now, and there is a surge of interest in this technology. Yes, so there's mass interest in production. So if people end up getting dissatisfied, yeah, that surge will go away. But yeah, people now have more faith in it, have put more faith in it. There's stuff happening right now. So there are case studies on Flutter for web website. You can actually check out the platforms that are running it. Okay, Sasha, thank you. It's awesome. So colleagues from Epam seem to be asking, is there a mentoring program in-house in Epam? Are there plans for mentoring? Are there something like that scheduled? Yeah, there is a global mentoring platform for Flutter. It's in terribly huge demand. So yeah, you can try enrolling in it. However, I'm really not promising you that you will get a mentor right away. The project needs, yeah, that might speed this up. But all the materials are on learning in open access. I mean, you can do self-study. There's video recordings, there's Q&A, there's homework involved, and so on. I mean, you can self-study at any time. A mentor, well, if it's just you wanting it, you're gonna have to wait. If there is a project need, you will have an easier time accessing mentoring. Okay, awesome, thank you. Maybe we should share this information. We should disseminate it this in-house. Like there might be some people interested in that, unaware of it still. Well, I don't know. There don't seem to be any more questions coming in. I believe let's call it a talk. Let's wrap this up. Thank you once again for being here. Thank you for talking about Flutter. Yeah, thank you for the invitation. Normally this is what the speaker is supposed to say in this situation, so this is me saying it. Okay, thank you. Thank you for the talk. The audience, this is just an announcement. We'll have an 8-minute break, give or take. We will be back in 8 minutes with a quiz. There's a special purpose quiz dedicated to hacker/security topic. It's going to be online. There will be some small bounty, some small prizes for that. Let me check with the organizers how big these are. I'm not aware at this point, but let's see each other in 8 minutes right here with the quiz. Thank you guys. Take care.